Hi everyone, welcome back to my channel. You are watching Education to All. Today topic differential equation exercise 9.3. These are all questions we can do by using of variable separable method. By observing the first question, dy by dx is equal to 1 minus cos x by 1 plus cos x. So then write the dy by dx which is given 1 minus cos x divided by 1 plus cos x. 1 minus cos x we can write as 2 sine square x by 2 and 1 plus cos x we can write as 2 cos square x by 2. In numerator and denominator observe 2 table common, so calculate it, cancel. Sin square x by 2 by cos square x by 2 we can write as tan square x by 2. In left hand side we have dy by dx, so cross multiply, dy is equal to tan square x by 2 into dx. Now the variables are separated, so apply integration on both the sides. By applying integration, integral dy, so we have y which is equal to integral tan square x by 2 dx. For integration of tan square nothing is there, so change the tan square in terms of secant square. So integral secant square x by 2 minus 1 into dx. So we have integral of secant square x is tan x. So writing it tan x by 2 and the coefficient of x we have 1 by 2, so writing 1 by 2 and the integral of 1, so I can write as x and the constant we write as plus c. So in left hand side y was there, so therefore y is equal to 2 in a denominator sending to numerator, 2 into tan x by 2 minus x plus c. So therefore y is equal to 2 tan x by 2 minus x plus c is the solution of the given differential equation. And similarly, solve the question number 2 as well. So question number 2 given as dy by dx which is equal to root of 4 minus y square. So in RHS we have only y variable, so cross multiply, we get 1 by square root of 4 minus y square into dy which is equal to dx. Now apply integration on the both the sides. So we have a formula integral 1 by square root of a square minus x square into dx which is equal to sine inverse of x by a and plus c. So by observing that, I can write this integration as 1 by square root of 2 square minus y square into dy integral dx which is equal to integral dx. By observing the formula and writing the given data as sine inverse of y by 2 which is equal to integral dx. Integral dx means x and plus constant. So then the sine inverse sending opposite side, I'll get y by 2 is equal to sine of x plus c, and 2 table also sending opposite side, y is equal to 2 sine of x plus c. Therefore y is equal to 2 sine x plus c is the solution of the given differential equation. Okay, observe the third question. We have dy by dx plus y is equal to 1. So then dy by dx plus y is equal to 1. So separate the variables, send y opposite side. So dy by dx which is equal to 1 minus y. Observing carefully, there is only one y variable, so no x variable. So cross multiply, we get 1 by 1 minus y into dy which is equal to so dx. Apply integration on the both the sides, integral. So in left hand side we have 1 by 1 minus y dy which is look like 1 by x dx format, so log I can write, but here I am having a negative, so applying the minus log of 1 minus y which is equal to integral dx. Integral dx means x plus constant. So whenever y having a log, so apply constant also in terms of a log, so applying the log c as a constant. Send this log c opposite side, so I'll get it as minus log of 1 minus y minus log c, which is equal to x. Both having negative, so taking negative outside, then we have log of 1 minus y plus log c, which is equal to x. Giving negative to opposite side, and this entire function is look like log a plus log b, so which I can write as log of ab 1 minus y into c, which is equal to minus x. When I remove the log, we can give the exponent to the opposite side, then 1 minus y into c, which is equal to e power minus x. But we required y alone, so c sending opposite side, 1 minus y is equal to e power minus x divided by c, and sending opposite sides by interchanging the terms, I'll get 1 minus e power minus x divided by c, which is equal to y value. And I'm writing this entire content as y is equal to, so 1 plus, I'm writing the constant minus 1 by c into e power minus x. And this minus 1 by c I can just consider as a, and replacing y is equal to 1 plus a into e power x. So this is a required general solution of the given question. Okay, given question number 4, secant square x into tan y dx plus secant square y tan x dy is equal to 0. Send this opposite side, then we get it as secant square x into tan y dx, which is equal to minus of secant square y into tan x dy. Now variables are not separated exactly. Here tan y was there, in the right hand side tan x is also there. Just cross multiply these both values and we'll get variable separables. Then secant square x divided by tan x into dx, which is equal to minus of secant square y divided by tan y into dy. Now observe carefully, variables are separated. Then now apply integration on the both the sides. If I consider tan x is equal to t, what going to happen? Apply differentiation secant square x dx, which is equal to dt. Then I can make this entire function as dt. Then it will be f of x, f dash of x. Then I write like logarithm of tan x, and here also same function. If this is tan y and its differentiation is secant square, but it having negative, so minus log of tan y. So remember, both contains log, so apply the constant also in terms of log, so log c. Then I'll send this opposite side, so we'll get the values as log of tan x plus log of tan y, and the log c sending opposite side, we'll get it as minus log c. Then it is look like log a plus log b, log of ab, so write the log of tan x into tan y, which is equal to minus log of c. So both the sides log was there, so cancel it. So still we have tan x into tan y, which is equal to minus c. This is a required general solution of the given question. E power x plus e power minus x into dy minus e power x minus e power minus x into dx is equal to 0. So variable separable we have to do. So send this opposite side. Then I am getting e power x plus e power minus x into dy, which is equal to e power x minus e power minus x into dx. So it is having a variable x in the left hand side. So send this to opposite side. We have dy only left hand side, which is equal to e power x minus of e power minus x divided by e power x plus e power minus x into dx. Now all variables are separated, then apply the integration on the both the sides. Integration. Then integral dy, which is equal to y, which is equal to integral of, observe the f dash of x and f of x, where f of x is equal to, consider as this one. If e power x plus e power minus x is equal to, let consider as t, then its differentiation, e power x differentiation is e power x, but e power minus x, so minus of e power minus x into dx, which is equal to dt. Then can I say that if this is f of x and this is f dash of x, therefore I can write as logarithm of e power x plus e power minus x plus c. So we required y value, so therefore y is equal to log of e power x plus e power minus x plus c. Therefore this is the required general solution of the given question. I hope everyone understood. Let us move for the question number 6. Question number 6 is given as dy by dx, which is equal to 1 plus x square is multiplied to 1 plus y square. So by separating the variables, we'll get the 1 plus y square opposite side. Left hand side 1 by 1 plus y square into dy, which is equal to 1 plus x square into dx. Now apply integration on the both the sides. Why? Because already variables are separated. By applying the integration, left hand side integral of 1 by 1 plus y square dy, this you can write it as tan inverse of y. So which is equal to integration separate for the 1 and x square. So integral of 1 is x plus integration of x square will be x cube by 3 and plus constant. Tan inverse of y is equal to x plus x cube by 3 plus c is a required general solution. Given as y log y into dx minus x dy is equal to 0. So send this opposite side, we get it as y log y into dx, which is equal to x into dy. Then separate the variables. So dy is the right hand side, so these both sending opposite side. Dx is left hand side, x alone sending opposite side. Then 1 by x dx, which is equal to in the right hand side we'll get 1 by y into log y into dy. Now variables are separated exactly, so integrating both the sides. Then in left hand side integral of 1 by x dx, so we have a formula log of x, and which is equal to, in the right hand side we have 1 by y into log y. Let's consider log y is equal to t, then it differentiation 1 by y dy, which is equal to dt, which means if I consider this is f of x, this is f dash of x, then I can again write a log of log y. But remember always, when the y component is come in terms of log, give the constant also in terms of log, so log c. In left hand side log x plus log c, which is look like log a plus log b, so writing as log of ab format, so log of x into c, which is equal to logarithm log y. Both the sides log was there, so cancel the logs. Xc is equal to log y, but we required the y value, so therefore I'm writing the reverse order. Log y is equal to xc and y alone required, so if I remove the logarithm by applying the anti-logarithm, I can write y is equal to e power xc. Therefore this is a required general solution of the given question. I hope everyone understood. So let us move for the next question. Now question number 8 given as x power 5 into dy by dx, which is equal to minus y power 5. Separating the variables, so send y to this side, x to the opposite side. Then 1 by y power 5 into dy, which is equal to minus 1 by x power 5 into dx. Then now variables are exactly separated, then apply the integration on the both the sides. Then this we can write it as y power minus 5 into dy, which is equal to minus of integral x power minus 5 into dx. So by applying the exponential formula, y power minus 5 plus 1 divided by minus 5 plus 1, which is equal to minus of x power minus 5 plus 1 divided by minus 5 plus 1 and constant c. So in left hand side we will get minus y power minus 4 divided by minus 4. In right hand side minus of x power minus 4 divided by minus 4 plus c. So in left hand side we got the same. So y power minus 4 divided by minus 4. But in right hand side take LCM as minus 4. And this minus cancel. So I can eliminate this negative in denominator. So if I take the 4 table common, then x power minus 4 and plus 4c. And this 4 cancel. Write the next step. So we get it as y power minus 4. So giving this negative to the opposite side, minus of x power minus 4 minus 4c, and the x power minus 4 sending to the left side, we get it as y power minus 4 plus x power minus 4, which is equal to minus 4c. And this minus 4c writing as a entire constant, therefore y power minus 4 plus x power minus 4 is equal to constant. So where c is equal to minus 4c, so just we considering that, therefore this is the required general solution of the given question. Given dy by dx is equal to sine inverse of x. This question we can do by using of variable separable method. So let me separate the variables. Dy by dx is equal to sine inverse of x. Dy is equal to sine inverse of x dx. Now it is very clear dx and dy is separated and all variables are also separated. Here no y variable but x variable and dx in the same side. So now apply the integration on the both the sides. Integral dy y is equal to integral of sine inverse of x dx. Integral sine inverse of x dx, we need to apply the by parts formula. So by applying the by parts formula, sine inverse of x function I am writing outside, integral 1 dx minus integral of f dash of x, means sine inverse of x in differentiation 1 by square root of 1 minus x square, integral 1 dx, again outside dx. This will become sine inverse of x, integral 1 dx means x minus integral over 1 by square root of 1 minus x square, integral 1 dx means x, and outside dx is still pending. And this again sine inverse of x is multiplied to x minus integral of x divided by square root of 1 minus x square dx. By observing this function, if I consider 1 minus x square is equal to t, then its differentiation minus 2x dx is equal to dt. But in numerator we have only x, so I will consider x is equal to x into dx, which is equal to minus 1 by 2 dt. Then identify carefully, we are writing x into dx together as minus 1 by 2 dt. That replacing, so here we have x into sine inverse of x minus, so then dx is written as this function minus of minus plus 1 by 2 integral of 1 by root t dt. Now again same x sine inverse of x plus 1 by 2 integral of 1 by root t dt. So I can write as 2 root t and at last constant. This 2 cancel. So t means we consider as 1 minus x square. So writing as x sine inverse of x plus root of 1 minus x square plus c. So which is left hand side we have y. Therefore the required general solution of the given question is y is equal to x sine inverse of x plus 1 minus x square plus c. Now observe the question number 10. Given as e power x tan y into dx plus 1 minus e power x into secant square y dy, which is equal to 0. This question can be done by using variable separable method. So send the variables to opposite side. E power x into tan y into dx, which is equal to minus of 1 minus e power x into secant square y dy. Here tan y is left hand side but secant square y dy on the right hand side. So send this opposite side by sending e power x. Here we have x term, so sending towards the left hand side 1 minus e power x into dx, which is equal to secant square y divided by tan y. And here we have a negative, so negative giving for the x variable, and here dy was there. So after separating the variables, we need to integrate both the sides. Applying the integration, then by observing the denominator, so let's consider 1 minus e power x is equal to t. Then what happens if I apply the differentiation? Minus e power x dx is equal to dt. Then it is becomes 1 by t dt. In RHS, answer tan y is equal to some p. So differentiate with respect to y. So then I can say secant square y dy is equal to dp. So in right hand side 1 by p dp. Then 1 by t dt means I can say log t. We can say log t, and write here log c also constant, which is equal to integral 1 by p means log p. Then replace the parameters, so log of t value is 1 minus e power x plus log c, which is equal to log of p parameter is tan y. In left hand side we have log a plus log b formula, so then we get log of 1 minus e power x into c, which is equal to log of tan y. So both log cancel. So writing the requirement, tan y is equal to 1 minus e power x into c. Therefore the required general solution is tan y is equal to 1 minus e power x into c.